Here we have an AWS Lambda architecture that uses Bedrock. So what's really interesting about this is you have a global scale serverless, very efficient way to use large language models because you can talk to the foundation model interface. You can put in extremely energy efficient resources. So a lot of people are talking about the paradox where as you get more efficient, you use more. But if you think about using high-level interfaces like, for example, serverless with Bedrock Foundation interface, and you even put your own tiny models or your distilled models on top of there, or even use these open source models like DeepSeek, this is a great way to take advantage of those capabilities, but also be energy efficient. So the idea here is you have an API gateway, you talk to this Rust Lambda, it has massive, incredible performance, basically as good as you can get, and you have a JSON request and you have model invocation. Some of the characteristics include cold start, so 50 millisecond, optimized binary size, average latency is going to be under 100 milliseconds, except for the model inference itself, and then extremely low memory usage. So a lot to like here. And then if we look inside of the code here, we first have, let's start with the error here. We have some errors here that we handle: runtime, Bedrock, serialization. We also have this provider concept, which I think is a pretty good pattern where you have a Lambda request, Lambda response, right? These are the data structures we care about. We also have response metadata. And then we have this provider trait here. And what's really nice about this is once we implement it, we have the ability to generate these requests to Bedrock. So you can see here, I do an async request. We take care of all of the bookkeeping there, and then inside of the Lambda, it is going to go through this handler and then give you back that response. So pretty straightforward here to get this cooking. Let's go ahead and kick the tires on this and see what happens. So first up, in one terminal here, I'm going to do cargo lambda watch. So what's nice about this is that we can see and actually simulate what would happen in production. This is really one of the key takeaways with Cargo Lambda, is that it gives you these amazing tools where you don't have to do anything and you don't have to mess with weird packaging problems. Now, next up here, what we're going to do is we're going to do a query called Cargo Lambda invoke. So if we really talk through what that does, it invokes the Lambda function locally, right? Because we have this emulator, and we pass in the flag -- data -ASCII. So what data ASCII means is that without having to store some kind of event file or whatever, I can actually pass in a plain text JSON data structure. In this case, it's query, and I say, what is Rust programming language? I mean, it could do other things as well. It could be, give me a Rust, hello world function, or a Rust add function, or debug my code, or whatever it is you want to do. And we also have the ability to toggle models. So for now, it's only using Anthropic Claude, but we also could do other types of models. But let's go ahead and kick the tires on this and see how it works. So first here, extremely fast, right? Because we have the ability to use Rust, but the network call itself that goes to the foundation model server is going to have to do some processing. It's going to go through and give us back our result here. So you can see it gave us a great result, right? Rust is a systems programming language that runs blazingly fast, etc. So really the takeaway here is that actually Rust Cargo Lambda for Bedrock is a killer pattern. Go ahead and take it out